Thank you for giving me the chance to hold my presentation here in this wonderful city of Warsaw, where I'm actually the first time in my life here. I will be talking about the advance and use of real-time tools in our live event industry, especially in the last couple of years. But first, let me introduce our company with a short show reel. So I hope everybody is awake now. So Evoke Studios was founded in November 2019, actually shortly before the pandemic hit the world. We are a studio bundling custom high-end visual solutions with content creation services. Our team is spread all over Europe, and which makes us a completely virtual organization in nature, working in complete remote teams all the time. The projects are prepared remotely. We go on site, some of the teams, and we meet sometimes only on certain jobs. All of our people are coming from live events background with some experience in content production and game design. We are 3 partners spread across Europe. Chema, of Mexican origin, he lives in Madrid. Chris, our Latvian, he lives in Riga. And I moved from Switzerland to Berlin 10 years ago. Evoke Studios is focusing on video-related services in these 4 markets. We are fulfilling jobs on a lot of corporate events around the world. We do concert touring for some amazing artists like Björk, Florence and the Machine, and we have done content and programming for artists like Ed Sheeran. We have worked for jobs in broadcast, from content to delivery, from AR shows in a stadium to just some plain casting shows. Our expertise in the world of XR also led us into some great virtual production in-camera VFX for Hollywood movies as well. As a 4th segment, we focus also on fixed installs. As an example, one of them is running in its 3rd year for Bosch in Germany. So in the title of this presentation, I used the words real-time tools. I want to talk a bit about what I mean by real-time tools, where they come from, and what advanced the use of it so much in the last couple of years. And then, last but not least, let's see how we can benefit from this trend in our industry. When I'm talking about real-time tools, I mean image render software that is capable of producing image output of a more or less big 3D scene in the moment it is demanded. In case of film, that means 24 frames per second. We have to update the image 24 times. This gives us only 41 milliseconds to calculate the frame. If we talk TV, we have to update the image 50 times a second, which gives us only 20 milliseconds to update the frame. In return, if the software or our scene preparation can achieve that, this means we can manipulate the scene and those changes will immediately be visible. We can do immediate light changes in the scene and move parts around. Interactively manipulate the scene. This real-time technology has been around for a while, and it's getting better by the day. The principal functionality we are using here is used in game consoles like Xbox and Sony's PlayStation, but also to write PC games. Hence the term game engines. And those games engines I'm talking about are also able to render a movie, meaning they can produce offline movies as well. These are some of the game engines on the market today. They are helping the game industry to roll out their games much faster in a shorter time frame. The games market is obviously a vast and lucrative market. Therefore, there are so many players. I do think that is absolutely to our advantage. From all those existing game engines on the market today, only a few have made any inroad into our live event industry. So I will mainly talk about today about the engines Unreal, a little bit about Unity, which are in use in our industry, plus one software that didn't come alive as a game engine, but learned all the tricks from them and was tailor-made for the live industry. This is Notch. So Epic Games' Unreal Engine has been around since 1998. With its newest version 5.1, it has really pushed the boundaries once again. If we want to create a photorealistic scene, this is the software to go. They have introduced a few very interesting parts of their software in the latest release, helping us to get even better looking lit scenes and better handling of complex and big scenes as well. Besides, constantly adopting more tools that help virtual production. They have really understood that through the development of the last couple of years, the user base is now bigger than just the game developers alone. Unity, on the other hand, is widely used in many industries for creating interactive apps. We can create different styles, looks, manipulate the render pipeline for comic looks and other styles a bit easier than we can do in the other tools. Award-winning short films have been done in Unity already. This means there is nothing in the way for us to use Unity for content production as well. In our eyes, it lags a bit behind the Unreal Engine at the moment if we solely look into the use of it in our industry. But you can do everything you can do in Unreal as well, also in Unity. And it has also a big user base. Notch was born as a real-time visual effects authoring and rendering engine with a compositing engine neatly fitted on top. This makes the technology ideal for the use in the live event industry. It has been optimized to manipulate live video with very little delay. But it has grown tremendously into a full-blown game engine level tool with some tricks up its sleeve that are way harder to achieve in the other two mentioned game engines, especially when it comes down to things that are building blocks for motion graphics like particle systems and cloners, which is very unique to Notch. All the easy compositing that can be done inside Notch itself is done on top. The possibility of exposing values directly to the media server, running it and manipulating those values live makes it the ideal tool for live shows. But now with all this information, what has happened that the use of those tools have exploded so much in the last couple of years, and what should we do with it? First, the quality. The constant advances of the GPU and therefore also the abstraction layers has created some really huge step forward when it comes to the render quality of those game engines can achieve. Especially, like mentioned before, with Unreal 5, Epic Games has pushed the photorealism of the scenes again much further than it already had achieved before. And at the same time, it did so in making our lives easier, heating up the competition again. Licensing, yeah? I do think this is a big one, even though it doesn't look like that in the first glance. In 2015, Epic Games opened their source code for everybody to use the Unreal Engine at their will. At the same time, completely they changed their licensing model. The news was that you only have to pay royalties if you earn money above a certain revenue through implementing their engine into your software. This has opened and democratized the use of game engines everywhere. Before if you did use AR and virtual studio tools in broadcast, those tools have used their own real-time render engine, like Visity and Ventus being examples of that. The opening of the source code of Unreal let new players in this field emerge. Softwares like Pixotope and Zero Density appeared, taking Unreal as their core 3D engine. They just had to extend the render pipeline to their use and had to put stuff around it instead of completely writing it from scratch. This created a level playing field, and over time, everybody integrated Unreal into their software in one way or another. Nowadays, let's say you want to do AR for your live show, for the streaming part of your viewers, you can choose from software that costs nothing, meaning plain Unreal that you just download, up to one that has licensing costs of 20,000 per year per camera. All of them are using the same core engine. They only differ. Can you move up the text a bit? Thank you. They only differ around additional functionality those software vendors have put on top of that core engine. On a side note, as this still stands, as we in the live industry use Unreal to create content or visualize, we are not writing software. We still don't have to pay any royalties for the use of Unreal Engine. Yeah, and then COVID happened. COVID has disrupted the market for in-person live events. A whole industry had to reinvent themselves. The move to virtual events, together with the availability of the game engines, led to a big advance in the use and knowledge of real-time tools. It meant that the whole live industry has put their hands and heads into those software because they had to. In parallel, the same technology also was starting to be recognized in the film industry, to be mature enough now that to be creating in-camera effects. Fortunately, the tools were already here since a while. They just had to be connected. Our XR demo video here shows some highlights from a few of the virtual production jobs we have been working on during COVID times and beyond. You can spot all three game and render engines, Unreal, Unity and Notch, used in different scenes, but I bet it's hard to distinguish them from each other. Already before COVID, these guys, the media server company, had been working on their XR stage software since at least 2019. XR, in our terminology, means the use of LED screens instead of the classic green screen workflow. XR enables live in-camera effects. This has many advantages for virtual production. Today, each and every company that makes up green screen software for virtual studios and AR does offer virtual production with LED walls as well. And all of them have by now integrated Unreal Engine. This has led to a huge step forward for the whole technology within our industry, which would probably not have been happening so fast otherwise. After our industry has now gone through the forced new skill learning in only a couple of years, COVID kind of ended slowly, and the world happily moved back to create in-person events again. But the skills are learned, and now how can we make use of it in a newly changed market with less virtual events than before? Even with less XR and VP productions coming our way, we of course wanted to keep using those tools and see what other uses it could have for us. As you will hear later, if we create our stages or event architecture in the game engine, it helps us not only to visualize the stage for us, but also let us use it as a sales tool. This is a nice way to create excitement for our client. Obviously, we can take those 3D game engine projects to use it as a previs tool in pre-production. We can use it to visualize our content on stage, to know if the content really does work how we intended it to be before being on site. With a very recent software plugin, we can use the same project for previs of the lighting connected to a real lighting desk. At the same time, the game engines have the potential to create a big change to our content creation pipeline. If we start using game engine in our content pipeline, we can run much faster through different locations, iterations of a look. Seeing what light changes is doing to a scene is instant, color changes and so on are all instantly visible and discussable. Creating and animating the content is the same like it used to be before, but at any point in time, I can see the end result directly on my screen, manipulate it without the need to go through several apps to see the achieved end result. If we use pre-rendered content, but we want to use parts of the 3D component for some real-time effects, we can do that as well. Reusing the same assets in the same software for two different output paths guarantees the matching of those looks very easily. And of course, it does speed up our render and time and reaction time. In live shows, there are many ways where our real-time tools help you create better events. Notch, for example, has been around for quite a while, for quite some time, and has been used to take live video input and distort it in many ways. We can use the engines to create live 3D content that is reacting interactively to sound or lights. And those game engines are perfectly to create scenes for virtual productions with LED screens and or green screen as well. Last but not least, we can create augmented reality moments in the stream for your remote audience. Now, Evoke Studios is not a light design house, but I still would love to put a spotlight on one of the recent use cases through the spread of Unreal into our industry. The development of a really interesting light visualizing plugin that I want to show you. The plugin is named Carbon for Unreal. It was released to the public in January 2021. It aims to take on the already existing tools like Visivik, Capture and all the others on the market. It integrates as a plugin that needs to be added to an Unreal project and that then lets you create your lighting rig. You can use the huge built-in fixture library. We're talking about 600 fixtures available at the moment. It is possible to patch directly inside Unreal, if that's what you want to do, or you can take over external data from Visivik directly and any CSV data. All you need to do at the end is hook up a lighting desk and you have a pretty accurate light previs tool. This is a short overview over Carbon for Unreal. One comment about expectations here, as rendering and calculating a light and the shadow of it is the most time-consuming part of the real-time render pipeline. Don't expect it to visualize thousands of lights just yet. Don't even think in combining it with streaming some live video into the scene as well. But it works for some smaller setups, and we will eventually get to the point that amount of lights will not matter anymore. And besides of the use for the light previs, of course we can now use Carbon for Unreal also to simulate real-world lights in our virtual world and have the light designer just use the tools he knows and the fixtures behave the way he knows. Okay, was a lot of theory. I would now dive into some projects we have done using game engines in different use cases. I want to begin with a real-world, very young use case. Our team was working on a TV show over the last few weeks, with the show being live just last Saturday evening. This job was for a live TV casting show in Switzerland. We wanted to see how we can adopt our TV show offline renderer workflow to include also game engines. Our original workflow has been honed and perfected through 15 years of experience. In TV, the pre-production time is really short. We usually calculate the creation time for a song between half a day and 2 days maximum. And sometimes it can happen that on set we completely throw out those contents overboard and create new ones in the camera rehearsal. The camera rehearsal usually gives us 30 minutes to see the content in camera. This is only possible if you have a vast library of building blocks. You can very quickly adapt to any situation and create new content very quickly. We have carefully chosen only a few acts of all of the ones that were in the show for the use of the real-time workflow, only where it would give us an advantage outside of pure render time savings. Like, for example, easier lighting on complex architectural scenes. As I said before, also the look development can happen much faster as you always see what you are going to get on your screen. But to become as fast as we are now in this TV workflow, this will require to rebuild our whole library and adapt the new tools to our needs. It is not just the render time that creates speed here, it's the tools that are there to help you to create the content. One of the acts required the dancers to basically dance around the world in places like a temple, a plaza in Spain, on the Brooklyn Bridge, and a beautiful surreal sunset in Africa. For us, this was a clear task to be better and easily solved in Unreal Engine. A natural-looking sky is already there. They have just a vast library of plants, and lighting in the scene is so easy and believable now through their new Lumen engine in 5.1. We could concentrate much more on the composition of the picture and lighting than waiting for the rendering to happen. For scenes like this, Unreal was the best tool looking at the natural lighting we wanted to achieve.
These four lonely walls have changed the way I feel, the way I I'm standing still.
Another example of content where a real-time engine helps tremendously is this piece that we have created to a time code, a particle watery world for a dance act. Notch is just absolutely the right tool for this job. Creating something like this with thousands of particles in a real-time engine enables us to really see from the beginning how the particle stream will flow and move with the music. The movement is defining the look. In Notch, we can create it and immediately look at the result. No waiting for pre-rendering of a movie, only to see that it went wrong. Everything can be done in one software: the particles, the animations, the grading, and other effects. In pre-production for the show, we had to check the scene scales as well, how they correlate with when they are combined with real people on the real stage. This meant for us not only using the game engine to create and render out the scene, but also use it as a pre-visualizing tool to check for right scales on the real stage with the real dancers. Therefore, we created this pre-visualization tool in Unreal as well, to easily check how things look on stage while building the content. On the left side, you can see an example of the complex scene. It's unlit and the shading is off for performance reasons. That's why it looks a little bit basic. On the right side, you can see an approximation of the TV show stage with this LED. When we move that camera in the city scene, it will project its final rendered image onto the virtual broadcast stage. This way we can adjust camera position, angles, and field of view of the virtual scene to perfectly match the scene. Once we are happy with it, we only need to render out the scene and pass it over to the media server team. Now I'm happy to talk about the tour of one of the top acts on the planet you probably all know, Ed Sheeran. We were really happy and proud to be having been working with his team, using exactly the real-time tools I have been speaking about. So let's dive in. Marka Cunniffe'a, the show designer of the last and also the current Ed Sheeran tour, has used Unreal to sell the very unique stage design to Ed Sheeran. Mark had always wanted to make a 360-degree stage in the round, but in order to truly sell it to Ed Sheeran, he created the virtual reality app with Unreal Engine and let Ed Sheeran dive into his virtual stage with a VR goggle. This way, Ed would understand and see how big and impactful the stage would be, and he went for it. At the same time, only through the use of the VR headset and the Unreal app, Mark could make it clear to Ed Sheeran that the size of that round stage there in the middle is so big that Ed won't be able to run from one corner of the stage to the other for the whole concert, because he would be dead after that. That led to the development of the revolving stage. So the outer part of the stage is turning. For the content production, a 360 stage has its challenges. Many basic tricks you would normally use on flat LED screens, playing with perspective, for example, won't fly in 360. We knew that. In order to get a better hold on what works and what not content-wise, we wanted to test our content as quickly as possible without too many in-between steps. As it has already been built, we happily took over that Unreal project file that was used as a sales tool to convince Ed Sheeran of this stage design. Our goal was to create a real-time previs tool for our whole content team and integrate it into our content creation workflow, and also to create movies for our client. create the possibility of fast content previs, we used the NDI toolset to have any content creation tool stream its video content into our previous project in real time. We added a few other small things to change the fog and the light in the stadium just for general environmental use. As a first step, we created the pixel map for all screens on one 4K image, which we provided to everybody that was part of the content team, plus an Unreal previous project. Our example here is the layout in After Effects. Creators can just add their content onto the appropriate screen on the pixel map and play it out directly over the NDI toolset from After Effects into our Unreal Stage Preview project across a local network. That content coming in over the network into our Unreal pipeline project, previous project, is then split up again for each screen according to the UV map, pixel map we have provided. In our previous tool, we are now able to freely move around the whole stadium and watch our content streaming in and play it back in real time while we are moving through the scene. Should we use real-time tools like Notch to create the content, we could manipulate light and colors in the content live while it is played back live in the previous tool itself. Here, just to recap the two tools next to each other. Of course, on the right side, instead of using After Effects, it could be Notch, it could be any other content creation tool that is capable of sending out NDI over the network. In theory, the content playback tool could also be Notch, which we were using actually for the creation of content for a lot of song visuals. In the content creation pipeline, we were heavily using Notch as our render tool. About 60% of the songs we were working on, we were using Notch in one way or another, mostly for the songs with 3D animations. For these songs, we used Notch as our render horse to mainly create pre-rendered content. Notch is ideal to integrate externally animated 3D content. Work on the perfect look and then render it out and build the several parts of it together into a inside the compositing tools. Most of the times we have to use After Effects to comp the content together into loops or sections. This could happen in Notch in theory, but it ain't always the right tool for everything, so After Effects still plays a role. After getting the building blocks of the content, we sequenced it all clips on the media server timeline in a way to keep content as flexible queued as possible and always be ready. I'm going to show you some small examples, parts of the content that we have been doing in Notch. For this one song, Thinking Out Loud, our content team decided to recreate the dance of a couple in the official music video. This digitized dance then would be placed into a digital particle and lights world. The idea was that content perfectly blends into the sea of little phone lights the spectators in the stadium would light. A sea of little light particles dissolving in space. So we started with getting the two real dancers into a Vicon motion capture studio in Budapest. Through this system, we exactly digitized the whole contemporary dance. After doing several run-throughs, we chose the best one and then cleaned the data. Because of the complex nature of the dance movements, this took quite some days actually. The dance movements data would then be applied to two 3D models of dancers. The next step was to simulate the clothings of the dancers and how they interact with each other. Only once that full, cleaned and simulated animation is done, we import those into Notch. In Notch, the real-time preview let us easily work on the particle looks, on the look of the dance couple itself, as you can see here. We can go through numerous iterations until we are happy, very fast, always with the final look in front of our eyes and on our screen. Rendering it out to a movie was the last step to be able to program a flexible, cute song. And the result of this was the sea of lights, where it becomes unclear where the LED starts and where the stadium ends, and the couple dancing in the middle of all those little lights. Ed Sheeran never uses timecode. He usually builds the song live on stage with his looper, and he loves to interact with the fans in the stadium. Hence, we never really know how that song will be played back the next time. This made us cut the dance into parts and put the pieces back together in the media server timeline to cue them in a very flexible way, so it would work regardless what Ed Sheeran had in mind on the current day. Now I will quickly show you some quick animation setups we used Notch for, the content and how it looked at the end. First, this was a setup for one of the animations done for Overpass Graffiti. The animation of the letter was done directly inside Notch via parametric nodes, then exported and colored via plain color ramps. And that's how it looked at the end on stage. This is part of an animation done for the song Shape of You. It was modeled in a classic 3D software package, then imported into Notch. The animation, the colors, and of course also the position of the camera can be decided instantly. This just naturally leaves us to play around much more and probably try out stuff that we would never have been able to do before. One use of the real-time I have only briefly talked about is the use of the real-time technology to manipulate live video. This is a standard repertoire nowadays in many concerts and shows around the world. In this example for Shape of You, we reused the same 3D assets that from the rendered content as a real-time animated 3D asset using the live video input as a texture. As the tool of choice in such application, this is done also inside Notch. This way we can get a consistent look. To create our offline content for the screen and reusing part of the assets in the same tool for the live video distortion makes live video become part of the overall look very easily. And that's how that looked on stage. The spectators around the world have been experiencing. Those amazing images, by the way, are done through the lens of the renowned event photographer, Ralph Larman. For the dark song Bloodstream, we needed many different animations, a lot of them requiring Ed Sheeran's head in many disturbing and dark settings. What you see here is some snippets of the content, parts of the animation we did within Notch. And I guess it gives you an idea how you could experiment here with textures, lighting and so on, very easily to create the right look, without even have to go down the whole render pipeline to understand how it will look at the end. That's the final design on stage of the real world for the song Bloodstream, which lasts about 6 or 7 minutes alone. This is Bad Habits. Lots of thrown around people falling and flying through the air. The whole simulation of crashing bodies was done outside of Notch in another software package. Then the simulated data was imported. It was very easy to play around with viewpoints, light colors, and saturations and whatnot in real time. And again, this is how that looked in the end. Before I come to the end of my presentation, I have some 2 or 3 more of these beautiful images from the set. One for Sing, very graphical song. Again, another one for Overpass Graffiti. I wish actually to love to show you videos instead of just still images, but that's of course not so easy to get hold on. Here you can see another Bloodstream picture. And then with this beautiful Galway girl image, I just can say it was really a tremendous honor for us to work on this magic tour set. With this, I'm coming to the end of my presentation. I hope I gave you a good overview over the possibilities of using real-time tools and game engines in live production with all of its different use cases. If you want to know more about it or have some questions, I will be around today and of course always available per email. Thank you for giving me your time.